Okay, so today I want to talk to you about the concept of equivalent fractions, which means fractions that look different but actually have the same value, and I'll show you why. First of all, let's start with reviewing what a fraction is, right, and what that means. So something like 1/2, okay, that tells you that 2 is the whole and 1 is the part, all right, 1/2. Graphically, we could represent it in many ways. For example, you have a whole, you take one of it, one part, 1/2 of it, and that makes half of it, right? So that's 1/2. 2/4, like you have a pie, you divide it in 4 slices. You eat 2 of those slices. That's 2/4 or 1/2. Okay. Now, talking about the concept of equivalent fractions. Why do we say that 1/2 is equivalent to 2/4? First of all, the word equivalent, spelled like this, all that means is that has the same value. Same value. That's all that means, right? So two fractions that are equivalent have the same value. But why do we say that 1/2 is equal to 2/4? Because the numbers are different, obviously. How can that be? So first of all, I want you to look at those two fractions here, right? So what do we have to do to get 2? We have to multiply, right, by 2. 1 times 2 gives you 2, right? To keep the same relationship, we also have to multiply the denominator, which is the number at the bottom, by 2. And when you do that, you get 4, okay? So that's why those fractions are equivalent, because what we did to the top, we also did to the bottom. Another example could be 3/6, right, is equivalent with 6/12. Once again, we multiply the top by 2 and also the bottom, the denominator, by 2. And that keeps the same relationship. To give you a more practical example, let's pretend that there's 3 friends that run on the Greenway, right? Person number 1 says that he ran 1/2 of the Greenway. The Greenway is 8 miles, 0 and 8, right? 8 miles. This is the whole length of the Greenway. He ran 1/2 of it, right? So 1/2 is exactly 4 miles. He ran 4 miles of it. All right, friend number 2, he comes back and he say that he ran 2/4 of it. 2/4 of it, right? So we're gonna divide the Greenway in 8 segments. I'm sorry, 4 segments. All right, and he ran 2/4. So he ran 1 and 2 segments, right? Which means that he still ran 4 miles. Friend number 3, when he comes back, he say that he ran exactly 4/8 of the Greenway, right? 4/8 of the Greenway. So I'm going to divide this line in 8 sections, right? 1, 2, 3, 4, 5, 6, 7, and 8, right? And he ran 4/8. So 1, 2, 3, and 4, right? And guess what? This is still 4 miles. So friend number 1, friend number 2, and friend number 3, they all ended up running the same distance. That's 4 miles. Because you can see how when you draw a line right here, even those fractions have a different appearance. This is 1/2, this is 2/4, and this is 4/8. They have different numbers. Eventually, they end up being equivalent because they all mean 4 miles in the context of the problem. So, what I would like you to do is to work on a few fractions and find at least an equivalent fraction for each. So let's see, 4/8, 2/5, and so 2/9. Okay, so I want you to find an equivalent fraction for each of those 3 fractions. I'll do one more example with you. Let's say that we have 3/7, right? What's an equivalent fraction to 3/7? Okay, so if I multiply the numerator by 3, that will give me 9, right? Because 3 times 3 is 9. Well, if I want to keep it equivalent, I also have to multiply the denominator by 3. 7 times 3 is 21. So now 3/7 and 9/21 are, or 29 are equivalent because we multiply both the numerator and the denominator by 3. So work on 4/8, 2/5, 2/9, find at least an equivalent fraction for each of those fractions.